Hello, welcome back to Math 7 with Mr. Passon. Today we continue our unit on probability. This is Unit 11, Lesson 5, Independent Events. Before we start this lesson, we're going to remind ourselves how to multiply fractions because it's kind of a big deal. We're going to be doing that a lot in this set. Alright, so first thing, remember when we multiply fractions, we multiply the numerators, that is our new numerator. We multiply our denominators, that is our new denominator. So 1 times 3 is 3, 2 times 4 is 8, 1/2 times 3/4 is 3/8. Now we might look to cross cancel, and I'm just going to grab this toolbar here. So remember that if we can divide something out of the top and bottom, divide both sides by 4, for example, that's going to make our numbers smaller and make it easier for us to do our multiplication. So 1 times 1 is 1, and 2 times 5 is 10. Alright, so 1/8 times 4/5 is 1/10. Now, this last one, again, we can definitely cancel. So there is a 9 and a 3. Divide both those by 3. So we get 2 times 1 is 2, and 3 times 5 is 15. So we get 2 over 15. It looks like I've got that kind of small, so let me go ahead and highlight that, make that a little bigger. Alright, so hopefully that is a pleasant or a relatively straightforward reminder. We did cover it earlier this year, but if you did not remember, that's how you multiply fractions. Now, when the outcome of one event does not, and again, that's kind of small, so let's make that a little bit bigger. When the outcome of one event does not impact the outcome of a second event, the events are called independent. Okay? Meaning they do not rely on each other and do not interact with each other. Independent probabilities can be determined by multiplying the probabilities of each event happening. So the probability of both A and B happening is the probability of A times the probability of B. Now I'm going to go ahead and make those bigger again and put them right around that multiplication sign. There we go. Oh, one too far. So the probability of two things happening, and remember when we multiply numbers, you see how they get smaller, right? Especially when we're multiplying by numbers less than 1. So two things happening is more rare than each thing happening, so it makes sense that we would multiply two numbers that are less than 1. Okay? Now, we're going to practice, and anytime we're going to talk about when something is independent is if it's in the same state you started with. So in this board game, students draw a card, replace it, and then draw a second card. So if you draw a card, and then you put it back, you have the exact same setup you had to start with. Alright, to earn 50 points, a student must draw a hard-eyed card and then an angel card. So we've got 2 hard-eyed cards out of 1, 2, 3, 4, 5, 6, 7, 8. So we've got 2 out of 8 for the heart-shaped cards, times, and then there's only 1 angel card, so it's going to be 1 out of 8 for that one. So if we multiply those fractions, now we can multiply before and then simplify after. So here I get the top is 2 and the bottom is 64, but that is the same as 1 over 32. Okay, 1 over 32. I divided the top and bottom by the common divisor 2. Okay, so if we did this many times, about 1/32 of the time, we would get that a heart card, a hard-eyed card, and then an angel card. Let's try it again. To earn 20 points, a student must draw a sleeping card and then an angry card. So let's look at sleeping cards. There's 2 sleeping cards. So that's 2 out of 8. And then let's look at angry cards. Angry cards, there's 1 angry card, 2 angry cards, so that is 2 out of 8. Again, I think it's easier to multiply or to simplify my fractions before I multiply. So both of those reduce to 1/4. So I've got 1/4 times 1/4, and that is equal to 1/16. Now, if we had multiplied it the other way, if we'd gotten 4 over 64, both of those are divisible by 4, and we still would have gotten 1/16. This is the simplified version of the answer. To earn 15 points, a student must draw an angry card or a laughing card. Notice or, so we're going to count both angry cards and laughing cards to get the total amount there. And then the angel card. So let's do an angry card or a laughing card, so they can draw this card, or this card. So that's 3 out of 8. Then we said the angel, there was only the one angel, that's 1 out of 8. So that ends up being 3 out of 64. Finally, to earn 5 points, a student must draw a sleeping card or a hard-eyed card, and then an angry card. So we're looking for a sleeping card or a hard-eyed card. That's 1, 2, 3, 4. 4 out of 8. Times an angry card, which I believe we already said was there were 2 angry cards. So that's 2 out of 8. And again, I would simplify. So for me, I'm going to say 4 out of 8 is the same as 1/2. So 1/2 times 1/4. And that equals 1/8. Okay? So this one will come up about 1/8 of the time. Now we finished this first page, and we're going to go ahead and go on to page 2. Now in page 2, you play the same thing we're going to just practice, and you play tic-tac-toe. So I'm going to leave it here, and I'm going to suggest you work these 3 problems. Then I'm going to go through them, and then, so go ahead and pause the video here, and work 3 problems. Okay. Kaylee has a coin and a number cube. She flips the coin once and rolls the number cube once. What is the probability that the coin lands tails up and the cube lands on a 4? So the coin landing tails up, that's 1/2 of the time. The cube landing on the 4, well, there's 6 sides there, so it's 1 out of 6. So our total equals 1 out of 12. There are 6 marbles in a bag. 3 are green and 3 are yellow. If you draw a marble, replace it, and then draw another, what is the probability of choosing 2 yellow marbles? Well, it's 3 out of 6 for the first marble, then 3 out of 6 for the second marble, because we replaced it. Both of those are 1/2, so we can do 1/2 times 1/2, and that equals 1/4. One card from the deck, one card from a deck of cards is selected. It is then replaced, and another card is chosen. What is the probability that the first card is a red card and the second card is a diamond? Well, half of the cards are red, and 1/4 of the cards are diamonds. So we get 1/2 times 1/4, and that is 1/8. Okay? Now, again, pause the video, work on these 3, and then we'll go over them in just a moment. Okay, what is the probability of getting 3 heads in a row? Well, the first coin, let's assume it's like we're doing either the same coin 3 times, or we're doing 3 different coins. The probability that the first coin is heads is 1/2. The probability that the second coin is heads is 1/2. The probability that the third coin is heads, is 1/2. So we get 1/2 times 1/2 times 1/2. 1 times 1 times 1 is 1 over 2 times 2 times 2 is 8. Neil goes to the pet shop and selects a treat for his dog. He chooses one, returns it to the bunch, and then chooses another. What is the probability that Neil selects a bone and then a collar? So there's 1, 2, 3, 4, 5, 6 elements. The probability that he selects a bone is 3 out of 6, which is 1/2. The probability that he selects a collar is 1 out of 6. So that equals 1 out of 12. Dexter has 4 different coins in his pocket. He randomly selects a coin from his pocket, replaces it, and selects another. What's the probability that both coins are dimes? Well, the first has a probability of 1 in 4 of being a dime. The second one has a probability of 1 in 4 of being a dime. So they're both being the dime is 1 out of 16. Okay, again, pause the video here. Take a look at it, see if you can solve the 3, and then we'll go over them. Okay, let's go over them. The letters of the, oh, that was annoying. The letters of the alphabet are written on cards and placed in a brown bag. What is the probability of drawing a vowel, replacing it, and then drawing another vowel? Well, there are 5 vowels, A, E, I, O, and U, out of 26 letters, times, again, 5 vowels out of 26 letters. Now, that is 25 out of 676. Now, I don't expect you to be able to do 26 times 26 in your head, but I have a piece of paper right here. I have it next to me, I have a pencil, and I worked it out there, but I've done this multiple times today, so I just remembered the answer. Let's go ahead and look at this one. 2 numbered cubes are rolled. What is the probability that the first number cube shows a 2 or a 3, and the other number cube shows an even number? Well, the first one is 2 out of 6 options. That simplifies to 1/3. The second one, we want to show an even number. There are 3 even numbers on a numbered cube, 2, 4, and 6. So that's 3 out of 6, which is the same as 1/2. So we have 1/3 times 1/2. That equals 1/6. All right. Mackenzie chooses 1 candle and returns it to the bunch, then chooses another candle. What is the probability that Mackenzie selects a polka dot candle both times? All right. Well, let's see. There's 2 polka dot candles out of 1, 2, 3, 4, 5. So that's 2 out of 5 times 2 out of 5, and that equals 4 out of 25. All right. So think about it. When we're doing compound events, more than one event, the probability of 2 things happening is a multiplication problem for independent events. Go ahead and write your own version of that explanation of what you learned today. There is an assignment in Alex, and we'll be going over more tomorrow. Thank you.